Um, we're going to finish up the notes we didn't, and examples we didn't finish yesterday. Other way around, please. This is topic 2.5, but this section is split into two separate assessment. It's 2.5A is all this graphing stuff that we're working on, okay? And 2.5B will be solving equations and rational expressions. We'll worry about that later. So 2.5A, we are going to start today with this example that I skipped yesterday. The steps using your yellow sheet, it's factor, so this is factored, okay? Then it says find the domain, and it would be everything except 3. The vertical asymptote would be at x equals 3. Does this have any holes? I know I only did one example about a hole yesterday. Do you remember when it has a hole? Nope, not necessarily. When there's the same factor on the top and the bottom, so something can cancel. Okay, and it could be an x out front, but something is the same on the top and the bottom. If that's the case, you have to find the hole before you do vertical asymptotes, because vertical asymptote will, if there's a hole, there's not a vertical asymptote at the same place. All right, this one has a vertical asymptote at x equals 3. The degree of the top, guys, remember this? Somebody explain to Tara. Okay, this one we're going to call top heavy. Why? Okay. Do you remember degree, Tara? The highest exponent power. So this is degree 2 over degree 1. So the phrase on your yellow sheet is it is top heavy. We're looking for the end behavior now. Notice when it's on the yellow card top heavy, it says what? No horizontal asymptote. Does that mean we get to be done? No. No. In Algebra 2, you got to be done. When it was no horizontal asymptote, you were finished. But in this class, where's my slide of the yellow sheet-ish? Okay, let me just look at slides all day. Oh, here it is. Oh my gosh. This time it says if it's top heavy, the very bottom here, it says no horizontal asymptote. It has an oblique or end behavior asymptote, and you must find this by dividing and ignoring the remainder. Do you remember that? All right. So back to my example. That was 100 slides this way, I think. Is that it? Yes. Okay. Real quick, we'll just finish up with this. The end behavior, can we use synthetic division to divide this? Okay. Don't tell Mr. Brizzo's class because she makes them do long division every time. There are some where you would have to do long division, but this one is just an x minus a constant, so we can do synthetic. Okay. Across the top would be 1x squared minus 7x plus 10. All right. 1 times 3 is, yep, bring down, oh my goodness. Someone fix me. Bring down the 1. 1 times 3 is 3. Add is negative 4. Multiply is negative 12. Add is negative 2. Good news is we get to what? Ignore the remainder. So what is this end behavior equation? Y equals x minus 4. So here's negative 4. Up 1 over 1 would give us this equation. Absolutely. You understand where that is what this is approaching? The further this way you go and the further this way you go, it's getting closer and closer to that line, which is called an oblique asymptote. All right. The other two things we did, and I said I was going to be done with this question, but the other two things you have to find are the x-intercepts, which is what makes the top equal to 0. So you'd have 2, 0, and 5, 0. And then the y-intercept, which is what we get when you plug in a 0. If I go back to the original, if I put in a 0, that'll be 0, that'll be 0, that'll be 0. What's left? Negative 10/3. Okay, so it was crossing down here at negative 10/3, and it crossed here at 2 and at 5. All right, let's see if we can do one that you have. Oh, this one's really ugly. I don't think we did number 4. You have this one? Okay. The reason it's so ugly is because the bottom doesn't factor nicely. We're going to factor it by graphing it, okay? But we don't want to graph the whole thing. We just want to graph the denominator. Can you just graph the denominator, please, and figure out where the zeros are? This is example 4 on the back of 9B, I think, on 9B. You find it? Okay. Just ignore what I'm doing up here because while you guys are finding that one, I'm going to get busy and type this whole mess in. You're supposed to just be typing the denominator in and finding the zeros so that we can factor it. Okay, someone get somewhere? Okay, that's what I had up here. I cheated. All right, so how does the top factor first? To get factors of 21 that make 4. X minus 7 and x plus 3. Does that FOIL back together? Give me a negative 21. Negative 7 plus 3 x's would be negative 4x. We're good? Okay, now how does the bottom factor because of what you told me over here? Good. Okay. Everybody get that? If these are the zeros, these are the factors. Okay. Let's go through the yellow card one step at a time. I want you to be real comfortable with what it says. Nolan. Got to be awake writing this down. We're on number 4 on worksheet 9B. Okay. We have factored form. That was the first thing it said to do, right? What is the second thing it says to do? Domain, okay. What is the domain restrictions? X cannot equal negative 3, negative 1, and 2. Because it's anything that makes the denominator 0. This is really important. What is the third thing it says to do? If there's a factor, x minus whatever. Okay. If there's a whole, we're going to cancel that factor, but first we have to find the whole. This one has an x plus 3 top and bottom. So we're going to say there's a whole. What is the x value at the whole? It's not positive 3, negative 3. Then to find the y value at the whole, we're going to now cancel this. Plug the negative 3 in what our worksheet yesterday, remember on 8.5a says called the beautifully reduced fraction or whatever I called it, okay? So we go back and we plug the negative 3 in the new reduced one. So what's negative 3 minus 7? Down here, if we put a negative 3 in here and here, be careful, negative 3 plus 1 would be negative 2. Negative 3 minus 2 would be negative 5. Oh, interesting. That's positive 10 though, right? So we have negative 10 over positive 10, which is negative 1. Okay, go back and write that in here. Now, you get to do the rest of the problem with this reduced one, okay? Except the graphing. You should always put the original one in when you go to graph it. All right, So what's the third thing on your list? Oh, the fourth thing then? Vertical asymptote. Are you sure we did the third thing? Okay. So the fourth thing is vertical asymptotes, right? It says if something is a factor of what? The denominator only? Is that how it's phrased? Okay, can't be a factor of the numerator as well, because that's the one we just crossed out. All right, so what's left in the denominator are the vertical asymptotes. They are at x equals -1, make sure they're equation, and x equals 2. We can graph those. -1, +2. Nolan, please take notes. All right, this had a 0, or a hole, I'm sorry, at -3, -1 over here. So I'm going to draw a big hole over there, because that should help us graph this in a minute. Anything else? I don't think we need to graph anything else yet. All right, are we on the fifth one on the list? X-intercepts. X-intercepts are factors that make what 0? The top. What makes the top 0 here? 7. We don't care about this one because we already did this as a whole. Okay? But if 7 is an x-intercept, that would be 7, 0. So it's over here. The next thing on the list is y-intercept, I believe. How do you find the y-intercept? Oh, okay. I always go back to the original one, guys. Look at, if this is 0, this is 0, this is 0, this is 0, and this is 0, what's left? -21 over -6. Reduce by 3, make it positive. 7/2, okay. Which is 3.5, so up here it should cross at 3.5. Hofbauer's a very big dot. All right. End behavior. Is that the next one? Is about top heavy, bottom heavy business? Yep. Okay. The degree of the top and the degree of the bottom. At the original one, this one was what? Degree 2 over degree 3, which is bottom heavy. And what does it say about bottom heavy? Okay. It was bottom heavy. So the end behavior, I'm going to write EB for end behavior. You can write horizontal asymptote. It's fine. It's y equals 0, so it's the x-axis here. Out on the ends, it's going to approach this. Now, interesting thing again, it can't cross the vertical asymptote, but anybody notice what just happened? We had a 0 out here at +7. That's right on the horizontal asymptote, right? So it's obviously going to at least touch the horizontal asymptote. All right, type this bad boy in. The original one. So you're going to have parenthesis, x squared minus 4x minus 21, close parenthesis, divided by parenthesis, x squared plus 2x squared minus 5x minus 6 parenthesis. Okay, do you need me to leave this? All right, I'm going to try Zoom 6. Well, I got fair window. How about you guys? Zoom 6. All right. So is that enough information to pretty much help us? Who's not getting that? Oh, somebody got typed in wrong? Okay. So it looks like this. I have a copy on my screen over here. So we're going to just go over here and make sure you avoid that little hole, and it's going down this way. Not going to be super picky. If you wanted to find an ordered pair or two, you certainly could. They're probably not nice ones anyway. And what about up here? I think it went down just a little bit after it crossed the Y, right? So I might just make it go a little bit lower. I think the minimum's there somewhere. And this is interesting. See, it's doing this, but it must cross here at 7 because we got it at a 0. So it's going to stay there, though. If I go back to the graph and I trace far to the right, it does become positive, but does it keep getting bigger and bigger? By a lot? No, it's staying really, really close to the y-axis, or to the x-axis. So if we're talking about, out at the end, what's it doing? It's staying very close to 0. So if you were writing end behavior equations, it would stay close to 0, but we have an end behavior equation right here, y equals 0. All right. Feel like we covered all the steps? Is there another one on, you have this one? Oh, let's do this one because this one is, what's different, guys? This is number 5 on, it's top heavy. Yeah, this is number 5 on the back of 9B. Okay. Then we'll do some off worksheet 10, which is your homework. We'll just do some of the homework problems together. All right. So what's the first thing we do?
Always factor.
Okay. So factored form would look like x plus 3, x minus 2. How did I do?
Yeah.
How does the bottom doesn't factor? Okay. So does this have any holes to worry about? No. All right. Domain? Good job. Vertical asymptote. X equals -1. Can anybody explain why we write both of those things? Okay. We write x cannot equal -1 because I'm giving you a chance to be lazy and not write it out in interval notation, right? And it is a vertical asymptote. It can't equal -1. That's true. But the asymptote or the boundary exists at -1. So this is not really part of the graph. That's why we do a dotted line. All right. Next thing is x-intercept, maybe? Is that what's next? X-intercept. How do we do that again? Top is 0. Yep. So where are the x-intercepts? -3, 0, and +2, 0. -3, +2. All right. Then we have y-intercept was put in as 0. I always go back to the original one for this. This is 0, this is 0, this is 0. What's left? Yep, right off the bottom of the graph paper. Lovely. All right, then all we're left with is end behavior, right? What's going on with end behavior? It's top heavy, and so it has no horizontal asymptote, but you don't get to stop there. You have to find the end behavior equation. And it says we have to divide ignoring the remainder, yes? So how do I do that? The little box goes -1, 1, 1, -6, bring down, multiply, add, multiply. Do I really care about this back thing back here? Oh, sometimes 0 is 0. Yeah, I'm not too good at that. Okay. I don't care about this last column anyway because it's the remainder, right? And I get to ignore the remainder. Did anyone else get this? Did I do that part right? So it's just y equals x, or 1x. Okay? This is our end behavior equation. Is that pretty easy to graph? Y equals 1x would look like this, right? All right. So when we go to graph this on the calculator, go to y equals, and we type it in. Okay, just kidding, Hofbauer, way to go. This is why my videos are never as good as Mr. Bruzzo's, because I can't use calculator. All right. Did you get this? Anybody? No? Zoom 6? I always type the original one in, x squared plus x minus 6 divided by x plus 1. I do that for two reasons. One, it should match up with what I came up with, so it's a check that I factored right to do something silly. But two, if you put it in as a factored, you'd need a bazillion set of parentheses for some of them. Do you remember how much we had factored on the bottom of this other one? Would have been a nightmare. Okay. When I'm looking at the graph, if you wanted, you could put in y equals x plus 1, or y equals x, as the asymptote that it's approaching. Okay? You don't have to do that. But I just wanted to show you this. It has a vertical asymptote here at -1. If we were to do this zoom out thing, look what happens. Pretty much all you see is this line, right? The end behavior. It is its end behavior except for right around that vertical asymptote. All right, we're good on this one. Oh, we didn't sketch it, sorry. So it was here and here. We good? All right, is that all of 5? Yay. By the way, so tonight your homework is to finish whichever of these you didn't get done last night and finish worksheet 10. And we're going to hurry through as many as we can on worksheet 10 together right now. We're going to have a competition. Abruzzo has challenged us to see which class can have more homework checks turned in at the end of this section. We are basic, and guys, turn something in. If we do 5 problems off worksheet 10 today, that's part of the homework check. Turn it in. I can't believe we do work together and you guys don't turn it in. Whatever, it's worth half of the credit, okay? The reward is, we have an option. I have the homework sheet you picked up today. Notice the bottom, it's blank for the date. We, in theory, are ready for this quiz next Friday. We will give you extra day to review and the weekend and not take the quiz until Tuesday the following week. If I'm seeing homework being done.
I thought we had a quiz tomorrow.
Yes, tomorrow's quiz is not, it's the no calculator stuff on this new stuff. And it's 1.5, the transformations. Okay. This is the next big quiz where the homework check's due. There's no homework check due tomorrow. Okay. So I'm going to check middle of next week, and I want to see that you've done some of these homeworks. All right. I should have my key out, and I don't. Guys, pick one that looks weird or funky or you want to try. On worksheet 10. 7. All right, let's start with 7. Oh, it's a good one. What can we pick out of the, do to factor the bottom? X plus 1 over X, take out, and then we'd have X plus 2. So does this have any holes?
No.
None. Okay. It is going to be bottom heavy. Let's start with the domain. Does yours have domain?
No.
Okay, well, tell me anyway. What is the domain? X cannot equal 0 or -2. All right. Vertical asymptotes is what our sheet says to do next. Since there isn't a hole, both of those domain restrictions are vertical asymptotes. X equals 0 and X equals -2. -2 and 0 is just the y-axis. So it should not cross the y-axis. We just found that out. So what does that mean? Is there going to be a y-intercept?
No.
No. If I put a 0 in here, guys, I get 1 over 0, and that would be undefined, right? There's not an x-intercept. A y-intercept. Just kidding. What's the x-intercept? Make the top 0.
-1.
Okay, so -1 over here is an x-intercept. Horizontal asymptote or end behavior. Yes. Bottom heavy. So there's a horizontal asymptote at y equals 0, which means there's not a slant asymptote. Okay, y equals 0 is this guy. Now, we do have an x-intercept though, right? It crosses here at -1. That's okay, because it's horizontal that it's touching. Vertical it can't touch. All right, I think we're ready to graph it. You guys go faster than me. See if you can find a couple nice ordered pairs once you get it in. What was it again? X plus 1? Thank you. Plus 2x? My memory of a goldfish. All right, zoom 6. Oh, interesting. Did we talk yesterday about why it looks like it stops on your calculator? Okay. It looks like it stops because if your calculator were to fill in all these pixels going straight down, even though they've done it over here, okay, would it be a function if it had a part that was perfectly vertical? Wouldn't be a function, right? It failed the vertical line test. So the calculator's like, well, I don't want to mislead you that it's perfectly vertical, because if you notice, if you trace down these, or up this, okay, it's hard to trace up because it's going to jump to the other branch. What is smaller for an x than 0.15? What if I just put 0.01? Do you see it's up at 50? It's not, it doesn't really stop, okay? The other thing you can do is you can make your y window smaller. If I only went like -5 to 5, it'll actually show you that, well, it still kind of looks like it's stopping, doesn't it? Sometimes zoom decimal makes it look really nice. There you go, zoom decimal, okay? Just know that they don't stop in the middle of nowhere, ever. All right, anybody find any nice points? -2, oh, that was the asymptote. -3, -3, okay. Anyway, I don't care. Let's just sketch it and move on. It was down here, yes? Did I do that right? And then up here? And then in here, what was it coming from the left? And crossing here and going down. Okay. By the way, guys, I just want to go back to the calculator for you and show you. If I were to do zoom out a couple times, do you see that all it's really doing is approaching, other than in here, okay, other than right in here, it's just staying at the y-axis, right, at the x-axis. End behavior means what is it really doing out on the ends? Okay, pick another one. 5. Ooh, 5. What can we do to the top? Take out a -2. So then we'll have x squared plus x minus 6. Is that right if I took out a negative 2? Okay, now what? Yep. So what do we get now? Got to keep that negative 2 out there, so it's going to change the shape. Good call. Denominator? X minus 4x minus 2. Do you everybody agree with DeAndre? Okay. He's the factor master. There is a hole. Okay, but before we write down the hole, we have to remember to do the domain restrictions. I know yours probably doesn't even say this. I don't know what yours does say. I don't have anything else. That's it? Oh, well, you need to write something down because you have to graph it. So I would practice writing it all down, but it's up to you. Did the directions say you're supposed to do more than that? Okay. Yeah, I stole it off 2 different worksheets from the same author, so it says to use all the stuff in the directions. What are the domain restrictions? X cannot equal 4 and 2. But both of those are not vertical asymptotes because one is a hole. So once we've written down the domain, we say the hole occurs when X is 2, and then to find the rest, we cancel this guy, and we plug the 2 back in. So I'd have negative 2 times 2 plus 3 all over 2 minus 4. Okay, the negative 2 member is still out there. This would be 5, right? When we add 2 and 3 and multiply that, we'd get negative 10. Did I do that right? The bottom is negative 2, so the hole is at 2, 5. Remind me we should, when we graph this, we should look about the hole this time, because I'll show you. Sometimes if you zoom in enough, you can get it to show the hole. All right. What about vertical asymptotes? Right. We don't have one where there was a hole. Okay. X equals 4. Intercepts. X-intercept, the top is equal to 0, which would be what? Yes, because if we made 2 into a 0, then it would be top and bottom and it would be undefined. So we can't do that. So we use the reduced one. The only x-intercept is negative 2 a 0? Negative 2 can't be 0, but what would make this 0? So negative 3 is a 0. The y-intercept is when you plug in a 0, go back to the original one. All that would be 0, that would be 0, that would be 0, that would be 0. We'd have reduced by 4, 3 over 2. Did that work? Which is 1.5, yes? No, what did I do wrong? That's the y-intercept, not the x, right? Oh, I wrote it backwards too. Genius, Hofbauer, no wonder you're confused. 0, 3 halves, which is up here at 1.5. Oh, I'm starting to see something here. What do you think? Do a little curvy thing here? Okay. End behavior. Top heavy, bottom heavy, equal weight. Equal weight means, yes, y equals leading coefficient over leading coefficient. I feel like we haven't done one of these yet for Tara. She was gone yesterday, guys. The leading coefficient of the top is negative 2. The leading coefficient of the bottom is 1. The deal, Tara, is if you put in a huge number, all this wouldn't matter, and this would divide out the huge number part, like 1,000 squared would be 1,000,000. You'd have negative 2 million over 1 million, so you'd just get negative 2. All right. That's why that works for everybody's benefit. So we have y equals -2. We go down here at -2. We put a dotted line. Does your graph paper look like it says 2 down there, not negative? I can't see the negatives on any of those numbers. All right. Now remember, if there's a vertical asymptote, can there be just one piece to this? No, there has to be something on both sides of the vertical asymptote. So I'm guessing it's going to be up here and then maybe down in this box over here. But type. You can go back and insert them if you do second delete, depending how much you already have typed in. Might be worth it. All right, I'm going to start with a standard window. Anybody getting this picture? Anybody not getting that? It's not really a great window because we don't have a real good idea what it is down here. We could look further to the right. How would I go further to the right? Okay, so if I made that like 20, now I can see it's getting closer and closer to something. I could even put in, if I wanted, in another pretty color here to put in the vertical or horizontal asymptote. We talked about wanting to see the hole though. Where was the hole at? Do you remember? Or +2, okay. So if I type trace 2, it says it's undefined, but I can't really see it on this graph, right? The one that sometimes shows it if it's in the window is zoom decimal. Yeah, it's not high enough. Let me try to change this. I'm going to double that. There's tricks, I know. Ooh, look how big that time it shows it. Okay. Sometimes it skips a single pixel. That one actually, I zoomed in far enough that you get a big skip. Most of the time, you're not going to see it. You're going to have to find it algebraically. All right, pick another one. Oh, I didn't catch it. Did anybody find a point on the other one? So we could, I'm going to go back here. Like, it's out past 6, right? That's not going to fit in my window. Darn it. Zoom 6. Trace. 6, -9. Oh, so it's way down there. It does go a little higher than that, but at 6, it's at -9. And then it goes up this way. Anyway, it doesn't have to be super accurate, but I did kind of like to know that it wasn't way over here tight to those asymptotes. Are we good? Yep. Ooh, 9 is a top heavy. Want to do a top heavy one? Let's do 9. We can do 10 as far as getting it factored, at least started, okay? But this one is gonna, can we take a 2 out of the top, right? That'll leave x squared minus x minus 6, which will factor how? And the denominator just has an x plus 1. Okay. Domain. Okay. Vertical asymptote. Did I factor wrong? Yes, we got the wrong signs on the top. Thank you. Way to be confident. Thank you. All right. Domain we still had right. Vertical asymptote. Yep, there's no holes, so x equals -1 is the vertical asymptote. Okay, x-intercepts, what makes the top 0? Is 2 a 0 out there in front? There's no way to make 2 equal 0. But if to make this 0, we'd have 3 and negative 2. So negative 2 and positive 3. Y-intercept, if we plug a 0 back in the original 1, gone, 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 negative 12 over 1. Yeah, that isn't going to show very well. So eventually it'll cross down here at negative 12. I'm not even going to try. All right. What about the weight of the top and bottom? Top heavy, which means we have to, right? So there's either a slant or some kind of end behavior equation. How do we find it? Synthetic division or long division, we got to divide. So negative 1, the 0 goes in the box. 2, negative 2, negative 12. Just always use the regular first equation, guys. Don't use factored ones. Bring down the 2, multiply. I got just a 2 and a 0 and then some garbage I don't care about. Did I do something wrong? Oh, yes, it would be. Thank you. Goodness. Why yes? Because I'm always. So we got y equals 2x minus 4, which is going to make a lot more sense when we go over here and graph it. It crosses way down here at negative 4, up 2 over 1, up 2 over 1, up 2 over 1. Okay, how many pieces are there to this graph? One vertical asymptote means there's 2 pieces, one on either side. We're running out of time, so I'm going to tell you it's going to go over here, and it's going to go over here. You want me to try to factor 10 for you? I think that's the only thing that's scary about 10 is that it was hard to factor. Yes, absolutely. All right. We are challenging the Abruzzoites. Finish worksheet 10 tonight. And I'll mark off who shows me that they did some of it tomorrow, okay? We'll keep tabs on who's doing some homework. DeAndre, I have a question for you.